Mm. Okay. Hi, everybody. Welcome to this instance of the Metaflow office hours. My name is Nissan. I work on the core Metaflow team here at Netflix, co-hosting this office hours with Savin from Outer Bounds. Today we have Roman, one of the Metaflow OGs, who will be giving a presentation about the latest features that we built in Metaflow, mutators, custom decorators, and lots of good stuff. Couple housekeeping notes. This meeting will be recorded and available on YouTube later in case you can't make it for the whole session. We do have a Slack channel, Ask Metaflow, where you can continue with questions after the meeting, and a GitHub repo, so like and subscribe. Without further ado, Roman, take it away.
Hi, thanks, Nissan. Yeah, so let's see, does this work? Okay. Yeah, so I'm going to talk about some of the new features that we released. As Nissan said, mutators and decorators. Let's see if okay, let me see, make my share. Okay, there we go. So I have a few code samples, so hopefully they'll work, but let's get started for this first. If you have any questions, feel free to interrupt me. And I can take them. Just raise your hand or whatever. Okay, so this is probably basic for people on this call, but who is Metaflow for? Initially, it started out primarily targeting data scientists and ML researchers. So the idea was to give them a tool so that they could focus on their work without having to worry about some of the infrastructure that is needed for that. So it abstracted away the infrastructure and platform, and it was mostly unopinionated about ML concepts. And there was a pretty clear separation, like we deal with infrastructure, whoever Metaflow is for deals with everything else. Another thing that I found this question was actually kind of loaded. What is Metaflow? So let's start with what it isn't. And maybe this will be somewhat surprising, but I hope not. It's not an orchestrator. It does have an extremely useful local orchestrator mode, so you can actually run your code locally, your flow locally, but it does rely on other orchestrators, in open source, Argo, Airflow, step functions, and internally we have a great orchestrator called Maestro, which is what Metaflow relies on to actually do production grade orchestration. So it really allows users to express their computation as a workflow, but it's not necessarily designed to be, state-of-the-art orchestrator. It's not a monolithic solution. You can take different parts of Metaflow, and the ones that I'll present today are other parts that you can take, or you don't have to. It doesn't just, it's not this big black box that you need to use all or nothing from. Yeah, so it's composable, but it's not, like, different components aren't actually strongly coupled. It's not a one-trick pony. One of the things for that is because it's very unopinionated about some of the ML things. So it doesn't solve one particular problem. So we at Netflix, we have people that use Metaflow for what you would consider standard ML things, and then others that just use it to kind of like do some data auditing, for example, and that's fine. What it is, though, is it provides undifferentiated boilerplate functionality. So like compute, some of the orchestration stuff like that users don't really necessarily care about. Packaging, persistence, dependency management, etc. It does have an opinionated view of infrastructure as well. So it does say, well, this is how you do compute. This is how we do orchestration. It has layered opinionated components that are somewhat optional. So in open source, you'll just have like @ray, @torchrun, etc. that basically provide you some opinions. And then the whole thing is wrapped in a smooth developer experience with a consistent UX. So why do I mention this? Because Metaflow is also a platform. It didn't really start out this way, but that's kind of how we evolved. So just a trip down memory lane, or just basic history for people who weren't there at the time. Metaflow started in 2017 at Netflix. I actually was not there at the time. I came in 2019. But this was the logo at the time, though. And it was targeting the variety of basically non-recommendation use cases within Netflix. There was already a group that was targeting recommendation use cases, but there were a bunch of budding ML use cases at the time that didn't really have a home and didn't really have any way to do what Metaflow did. So that's how it started in 2017. In 2019, we open sourced it. At that point, this is kind of what things looked like. We had Metaflow at Netflix, and then we had a completely separate code base in open source. The code bases were similar, but not identical. We had actually made a lot of changes when we open sourced it. We removed some code that was specific to Netflix, and we added specific other code specific to AWS, like batch and things like that. Step functions came a couple months after that. But so there was a single team developing both. So it was fairly straightforward to keep things in sync. You just had to do 2 commits, and that was kind of okay. And then in 2021, Outer Bounds split out. So a few people left from Netflix to start Outer Bounds. At that point, we still had 2 code bases. I know it had been like a year and a half, but that still was the case. So we had Metaflow at Netflix and then a separate Metaflow. And at this point, there were potentially multiple development teams. So one at Outer Bounds and one here. And then there was potentially also multiple development directions. Like in Outer Bounds, they wanted to support more different clouds. And internally, we weren't really interested in that. That wasn't a priority since we all run on AWS internally. So that kind of was a problem. So from this came the current view, which is what we have today. And this is where Metaflow extensions were introduced to basically allow for a single code base. So we had a single Metaflow open source code base, which is used both externally in open source and internally. So code engineers within Netflix use the open source Metaflow code base, as well as additional extensions that are developed within Netflix. So these add specific infrastructure. So compute, we use Titus instead of Kubernetes, for example. Orchestration, I already mentioned Maestro. And we have other things that are only internal that we haven't open sourced yet. So that is what we built, mostly to answer this problem that we wanted to have a single code base for all the shared components. Other companies took a similar approach. I think Outer Bounds also uses this. They have their own extension as well that adds a few more things. And this is the current state. So this was great. So it kind of became this accidental platform. Metaflow always had a plugin infrastructure, just to be clear. Like if you look at the initial code base, you do have a plugins directory and it had stuff in it. But it wasn't initially designed to be extensible. It was really just one code base, and we just had kind of structured it with like different plugins. So the real drive for this was the need to unify the code bases. So it wasn't like it was necessarily a conscious decision. You know, people say, "Oh yeah, we thought about this long ago." No, not really, but this is how it came about. But the extensions were kind of difficult to use, or they still are difficult to use. They require kind of a high cognitive overhead, and I'll show you why in a minute. But that didn't mean that the need for customization wasn't there. So as Metaflow usage grew, we also realized that some of the stuff that we were doing in extensions, other people wanted to do it. And some brave souls actually do use extensions as well in their own companies, and that's fine. And it works. But you might want to do customization that doesn't require a full-blown extension mechanism. And that was what we have addressed recently this past year. So just to recap a little bit, what you can do with extensions, you can do pretty much anything. You can add, remove flow, step decorators, loggers, data stores, whatever Metaflow, a bunch of Metaflow components. You can add or remove Metaflow commands as well. You can add, remove exceptions, top level objects. So you can add like from Metaflow import XYZ, you can add those stuff. You can even override whole files, create aliases. So you can create different names for different components of Metaflow. You can package any code you want. You can override configurations. You can set default decorators, and probably forgot a bunch of other ones. All of these, again, came from when we were merging the code base. These are the things that we needed to do. And so this is the mechanisms that we implemented over time. So just focusing a little bit on the decorators. So the add, remove, flow, step decorators, because that's kind of, since decorators are the most visible part of the Metaflow UX, a lot of people ask, well, what can I do with decorators? So if you look on the Metaflow repo, you'll have this I don't expect you to read this, but there's this life cycle document, a PNG or SVG, I forgot, in there that basically shows this is what happens when a Metaflow flow starts, or a step starts, really. And it does a bunch of stuff. And with extensions, you can basically plug in at all of these little boxes, pretty much. Just let's go over them very quickly to kind of like show what you can do. The idea, again, is not to teach you how to write an extension, but just to show you the complexity that you needed to understand to be able to write one, because you basically need to understand what's happening in this graph. So if we split it up a little bit, you'll have the first part of it, which is, the decorators get initted, both the flow decorators and the step decorators before the command like run, resume, Maestro or Argo functions gets called. This and part that you also have to understand, this will actually get executed multiple times for a single step. Metaflow runs once when it first launches. Then if you're using batch, it'll launch a monitoring process. So this will execute again. And then when you're executing remotely or locally, it'll execute again for your actual step code. So typically this is used for arguments validation, compatibility checks. That's what, if you look at the code base, what we used it for. Then we have the whole packaging business. This basically creates the package that will get executed remotely and is also stored in S3. And then we have the actual interesting part, which is the execution. I skipped a few parts there, but for purpose of this talk, this is enough. So you can execute something before the step executes. Then basically the user code executes, and then you can execute something after. Kind of mostly is what this allows you to do. And this is actually fairly common to do something before the step and something after the step. And this was actually something that people wanted to do. Like if we kind of like ask, well, what do you want to do when you add a decorator? There was a lot of validating stuff. Another common use case was like, well, you guys have a great packaging system, but I just want to add my little utility function. How do I do that? Also, like, profiling, you wanted to add something before and after the execution of the step, and a few other things, but these were the kind of the main ones. So kind of decided, well, can we do this without having users kind of understand this thing? And the answer, fortunately, is yes. And so the first thing we introduced, sorry, I'm talking a lot. Is there any questions, by the way? No, everyone's happy? Okay. So the first thing we introduced is what we call user step decorators. So unlike Metaflow decorators, they don't have the complicated lifecycle hooks that you just saw in the previous graph. They have two primary hooks. One is pre-step and post-step, which is what can I do something before the step and what can I do after the step. And during these pre and post step, you actually do have access to the step itself through the flow argument, which is basically gives you access to all the artifacts within the step. You have an optional init, which allows you to basically replace the __ init and do something when the decorator is created. So this is kind of the basic structure. We made it a little simpler because we thought, well, writing a class every time you have to do this might be a little annoying. So before that, actually, they're like any other decorator. You can also use with to include. So if you define one of these decorators, you can do -- with. You can import them from any existing package. And one of the cool things about them is that the package that you import them from will automatically be included in Metaflow code package. So you don't have to have them in the same directory. Like I mentioned, they only allow before and after execution, but they don't require any deep knowledge of Metaflow internals. And hopefully the API will not break. They are fully supported and documented. So we will maintain backward compatibility. So we made a simpler version, as I was mentioning, using effectively this decorator called @user_step_decorator, where you can define your step decorator. You have the same kind of thing, the step name and the flow and the inputs, if you're like a joint step. You have this additional argument, which is attributes, which is everything that was passed in the initializing of the decorator as a quarks. This syntax does not support passing args to the decorator, but it supports quarks, which is usually enough. And the way it's structured is kind of the way you would expect it. You can do something first, then you yield, and there's actually a little bit, you can actually yield something. I'll show an example of that. And then the yield will raise an exception if the step raises an exception, which you can then catch and do something. Like, for example, you can gobble the exception and ignore it, or you can raise another exception, or I'll show this weird syntax at the end. You can return what you want for the next step argument. So I'll show a few examples of how what you can do with this, and it's actually surprisingly useful for this. So the first one is a very simple profiler. So this is probably, I think, the first thing that we did. Some of these examples are in the docs, some are not. So, but this one is. So this is how you would look. It would look like on the left. You can just define your profile function using the @user-step-decorator, as I mentioned, and you just basically do what you would expect from a profiler. You figure out when you're starting. You execute what you need to execute, and then you compute the duration of it. And then the use is extremely simple. On the right-hand side, you can see that effectively the flow, you add the @myProfile on top of your step. And that's it. At this point, the start step will be profiled, and you'll effectively get at the end of the start step something like task start completed in the duration. I don't know what task key is. Okay, it should be step name. Sorry about that. A slightly more complicated one. We can actually keep all these durations and kind of like have them at the end, or like print them at the end. So this basically does a little bit more complicated. It does the same as before by timing the step, but it also basically stores all of them in this artifact called _durations that will get propagated all the way till the end. You can see it has a little bit of logic to basically deal with join steps so that durations can get propagated properly and merged with all the durations that you have. And the durations is keyed by effectively the task path spec, so the step name and the task ID, to make sure it's unique. And then lastly, and then I'll show how this can work. You can then print out this information, and you can have a print function that is also a step decorator, which basically reads this durations that is present effectively in your flow at this point, and then just prints out some, whatever statistics you want. You can do anything you want here. You can log it to some Elasticsearch or anything like that. So if I can show a little demo, let me see if this will work. Let's see. I'll present something else. Okay, so yeah. Okay, so is this visible? Make it a bit bigger. Okay. Oop. Okay, so this is the exact code that I was mentioning. You have the profile up here, and then you'll have the print profiler down here. And the simple flow is really simple. It just adds my profile. And the last step over here, you'll see that I also have a print profiler at the very end. And so that's it. And so I just run this. It does exactly what you expect. You'll see that at each step, you'll have the time that it completed. This is not very interesting, but like the start one has actually a sleep, so it says 1 millisecond, and at the end, you'll have some average statistics of what happened. So nothing very fancy, but it does exactly what you want it to do. Okay, so okay. So moving on to what else you can do with step decorators. Any questions so far? Okay. So this is the code that I showed you. We will actually improve this later. Right now, it's looks fine, but it's a little verbose. You have to add this @myprofile everywhere, which can be annoying. And the user, may forget it. So not great. And then you have this print profiler at the end, which is also not great. But it does work. The other one, this one is not in the documentation, but this one is pretty cool too. Suppose that you want to do some filtration. So in this case, the code says that, you have all these countries, US, France, Spain, Mexico, and you want to, process something on these countries. You can add a filter, and there's actually a use case for this, but so the filter is defined on the left here, and you'll see that it does something similar to before. It doesn't do anything before. It doesn't really need to do anything. It yields, it executes the step, and then it actually will override the country's variable to say, well, it should only be the ones in Mexico or Canada. And it returns this weird syntax. The syntax there, the first argument is effectively the exception that you want to re-raise, in this case, none, because you don't want to have an exception. And the second one is the arguments that are passed to the for each. So effectively, you're not really changing it, but you're telling Metaflow you need to reread countries. So like we have for each equals countries. Oh, sorry. On the right here, that says this is the argument. Here you're telling it, okay, it's still for each equals countries. You could technically change it to something else. But, this segment, this code here is executed before you get to the yield. So you have to effectively tell it again, like, please reread countries in essence.
Countries is not updated in the artifacts.
It is also updated in the artifacts, but the way Metaflow works, when you execute the next statement, it will add some tracking variables that read countries at the time when it's processed. And so you're basically telling it, read it again. Specifically, it looks at the length of countries to compute how many numbers of how many for each steps there will be. And so since we're shrinking it here, you would need this. If you want to get really specific, if you don't change the number, you don't actually need to return anything and it'll just work. But for this case, you need to change it. And you can make this, a little bit more fancy. This is the other part that I wanted to point out, is that these decorators work with another feature that we released a while ago called configs. So you can actually parameterize your filter, in this case, using whether or not you need to do the filter with just a configuration here. This is a dumb example, but it'll give you the idea of what to do. And you can see that effectively attributes is where you'll get this value that shows up here. So this is the same example as before, except now it's configurable whether or not you do filtration. And then the last, why would you want to do this? This is actually not completely useless. You can effectively write your code and kind of have a decorator that tells it, hey, I want to just run parts of my my code, not the whole thing. And this is like, you're doing smoke testing. This should also be smoke test in here. So here you have the same thing, except you also give it like the variable that within the flow that you want to modify or filter on. And I can demo this too. Okay, so. Okay, so the simple one that I just mentioned first was this one, where you just have a filter like this, and you just filter the countries with the do filter. And so if you look at this, you can just you can run it without anything like this, and it'll just not do any filter. You'll see that here effectively processes 4 countries. And then if you now run it with a configuration like this to pass it saying, I want you to do the filtration, then it does the same thing, except now it only processes Mexico. So this is pretty straightforward. And so you can see that you've effectively kind of modified what your flow executes using a configuration and a decorator. And if you the smoke test is very similar, except like I mentioned, you can pass it like the variable that you want, and this does exactly the same thing. Oops. And here, this is just like the do filter. It will only process one of the nodes. Okay. Any questions so far? All right, so let's move on to more fun cases. Okay, I know we have conditionals, so maybe this is less cool. But if you're using step functions and you don't have conditionals, you can actually do a poor man's version of a conditional. It's not as fancy as the actual conditionals that we have. This only allows you to choose one step, but it does allow you to do something. And this was kind of another demonstration of what you can do with step decorators. I mentioned that you could effectively return something with the yield function, and this is an example of this. So in the left-hand side, you can see that you will look at the variable that you need to make your choice on. So in this case, it's passed through the attribute var, and then you'll basically get the step from the flow that you select based on the choice. So notice here effectively it's slightly different than conditionals, where conditionals, the variable is at the end of the step. Here, in this case, it's at the beginning. You could modify it if you wanted to make it at the end. Well, no, actually, since you need to yield the function, you couldn't, but similar concept. And here you basically yield the function that you want to execute. And what this tells Metaflow is, like, instead of executing the step that I have, you execute this other function. If you yield none, which is the default, you will effectively execute the step that you have. So in this code on the right, you have a select parameter that you can pass through the command line so that I can actually demonstrate this. You have a start step, and then basically this choose step will either execute itself if none of the choices are valid, which is the default here, like nothing, or it'll execute A or B for this step, and then it'll just continue on. And you can see that each of these functions looks like a step. It's not technically a step. It doesn't have @step on it because you don't want to tell Metaflow that you have an A or a B there, because otherwise they'll complain saying you can't reach them. But you can actually execute them in place of choose. So
Do they need to all have the same next?
they do. Yes, you can't. So the structure of the graph is not changeable that yet. That's something that we might work on. I'll talk about at the end. But yes, as far as Metaflow is concerned, the graph looks like start, choose, end. And then whether A or B executes as choose, it doesn't really care as long as it goes to the same location. Otherwise, because at this point, A is standing in for choose. So if A executes a different self.next, the Metaflow will complain saying the static graph said that you were going from choose to end, but you're actually going to some other step. So yeah, I can show this too. So yeah, this is as I mentioned, the flow, nothing fancy. You just have, I have my profile. I don't know. I have this here.
There's a question on the line.
Oh, yes.
Let me just read it. Are class full level decorators possible? Thinking of use cases where we'd want to have a similar pattern of the conda base, where defaults to a condition that can be overridden by step level decorators.
Yes, you do have. Well, you have a flow. You can. So we don't have user flow decorators. There was a reason why we didn't implement this. But we do have flow mutators that you can actually use to do the same thing as the conda base. And I'll get to that towards the end of the presentation, where effectively, if you think about it, conda base or pipe base or any of those other or those type of decorators, actually apply something to each step. So you can actually write a flow mutator, which I'll get to a little later in the presentation, that will modify each step to add what you want there. Does that answer the question? I don't know who it was, but
Brian.
okay, Brian, thank you. Okay, so yeah, this is just the flow, as I mentioned. I even have my profile. You can stack these together, by the way. So I'm just mentioning that you can stack them too. In this case, you can see here. So if I execute this, so if I just execute it with nothing, it'll basically execute as if no choice was made. So this is the choose step itself, and you know, and it also has the profile information, as you can see. And then if I execute the B, for example, you'll see that it says I am B. But notice that as far as Metaflow is concerned, it's still choose. There's no B involved. It's just the code inside it changes. But as far as Metaflow is concerned, it's still choose. But it does print I am B, which is the B step. And then same thing for A. But so yeah. Okay. So let me continue here. All right, so that was a cheap conditional. Again, you now have full conditionals, so not as useful, but it demonstrates that you can return a function in this user step decorator to do whatever you want, and you can also stack them as well, as I mentioned.
You can't stack choose, right?
No, you can't you can stack user step decorators. I mean, technically you could stack, no, you can't. So yeah, you're right. You cannot stack choose. As soon as something returns something else, it doesn't continue up the stack. Okay, so where we are now, like, and what you wanted to do with user step decorators. So we've kind of covered the pre and post execution handling. I would argue that you can actually do more than just pre and post execution handling at this point by like overwriting the code, etc. So this is where we are. So we'll continue to put green check boxes for all the other stuff. All right, so Brian, your next thing, flow mutators. Now these are really cool, I think. Anyway, they kind of look similar to decorators, but these there is no decorator version as much. They're always a class, but you can use them as with @mutator as I'll show. So there's three main functions for this. The initializing, which is again the __ init, is just called init because we need to do a bunch of other stuff in the __ init. There's a premutate and a mutate, and I'll get into the explanation of what premutate and mutate correspond to. But suffice to say that they are two hooks that you have to affect the flow, and you have a bunch of things in these. So these are passed a flow, which in this case is not the actual flow object, but is a mutable flow, and it has a couple of methods on it. Some of them just basically give you the information, like you can iterate over all the steps, you can iterate over all the configurations, you can iterate over the parameters, for example. And then you also have some modifiers. So you can add decorators, you can remove decorators, you can add parameters, you can remove parameters, and you can that's at the flow level. And at the step level, so you also have, oh well, they're in the next slide, but we also have step mutators, which I'll get into next. But flow mutators are applied effectively exactly like flow decorators. They are also packaged automatically. You can access the flow's parameters, configurations, and steps. You can add or remove parameters and flow decorators. So you could technically add, you can add, for example, a @project, which I'll show, I have an example of. And you cannot yet add configurations. I thought about this, but they used configurations. So if you have mutators that use configurations and can add configurations, it gets really complicated to kind of reason about and to do the ordering right. So right now, and maybe this is something that will change, but right now you cannot add configurations using flow mutators, but you can definitely use them, which I'll also show. We do have step mutators. They're less useful. I would say the only thing that are kind of useful is that you do get access to the steps in the flow mutator. So you can basically do anything you want to do in the step mutator directly in a flow mutator. But, you know, they're there. They just typically apply just to the step, and they can just modify the step. And you can basically add or remove step decorators for that step. So here's an example of what you can do, and this is what I was mentioning about adding flow level decorators. So here's the decorator, how it would look like, the flow mutator. It's like one, and this thing basically just adds a project decorator if your flow does not have a project decorator. And this is how it's used. It again looks exactly like a decorator. You do at default project. In this case, there's no init, so you don't need to pass any arguments. And what this will do is it will add the project decorator using these quargs, so like the testing and branch dev. And then there's a handling of what we do with duplicate decorators. In this case, since we don't want to add something if a project decorator already exists, you basically say, if you already have a project decorator, then ignore it. Ignore this one. Ignore adding this one. And so just demonstrating this one. Oops. So in this case, in this example, I don't have a project. So I just commented out the project decorator. So what what you would expect is effectively when I run this, you'll see that the project's name is testing and the branch is dev. So that's what you should do. That's what it should work. And you can see that, yeah, there you go. And if I do have a project decorator in here, and you're like, well, I know I have default projects. Why do I have both and stuff? There's actually a reason. I'll show. You can actually do this more fancily, where the user doesn't really know that they have this default project. This is kind of something the platform wants to do. But I'll show this later. But so here you can see that I have a project decorator, and it just uses my project, so it doesn't insert another decorator on top of it. Okay, so this was pretty simple. Nothing mind-blowing. But you can do more cool stuff with it. Okay, so that was a default project. How you can effectively use a flow mutator to add a flow level decorator. If you remember back the annoying profile thing before, you had to add, at my profile all the time. Well, if you can have a flow level mutator that basically does that same thing. So it will again read configs, and then it will basically add decorators to all the step, and at the end step it adds a print profiler as well. So if you look at that, oops. I should hurry up actually. Okay, so this is the add profiler flow, which just, has this and then just adds the flow at the end. And so if I run it, and I'll just set it with the settings like this, you'll see that it just basically added all the steps now have a profile on top of it. Okay, I will speed up a little bit because I actually have a few more things to show. Okay, so that was that. The one that's pretty cool actually is you can do parameters, and they will actually allow you to modify the command line at the same time. So here you're adding these two parameters, current date and this one start date. This one is default, this one is required. So if you run this flow without actually specifying any arguments, it'll ask you, I need a minus current date. This is pretty cool because the command line effectively is being parsed in two times. Like it will actually modify what the command line expects based on this flow. So just to kind of like how this works and the difference between pre-mutate and mutate. If you remember the initial kind of life cycle for decorators on the right here, this is how the mutators kind of fit in there. So we start the command line processing, we load configurations, you init the mutators. This is basically giving the arguments. You run pre-mutate, Then you validate the environment, so you're over here. Then you finish the command line processing, you attach decorators, so this is all the minus width that effectively are now on the steps. Then you run mutate at this point, and then you do the step init or technically the flow init too. Like you're basically here. So all this part happens in between, all this part happens before. So yeah, the reason for those is that the pre-mutate allows you to do more stuff. You can do stuff before the decorators get hit, and you can effectively modify the rest of the command line. So by adding parameters, that modifies the command line. If you're watching carefully, you will notice that technically you can add a flow level decorator that can add top level options. That doesn't quite work well, but hopefully you don't have to do that too much. And then mutate is after the command line, so it has visibility on everything that was passed through the command line using width. So you can, for example, modify the decorators at that point. If you did it in pre-mutate, you might not get visibility into what gets happen down here. Okay, and the last thing I want to show about this is that the reason that you would want to do these types of mutators is you can actually have kind of a base flow spec. Let's say your company wants to define these things by default, like the profiler or the default project. You can add them all over here. And then you can basically have your users just inherit from the company's flow spec as opposed to flow spec. And all this behavior will be applied to this flow. So like, for example, if you had the default decorator here, the default project here, the user wouldn't really see it. And that's why, if they added their own project, it'd be fine. If they didn't, then the company's policy would take over. So this is actually pretty nice for platform builders. You can build your own kind of what you want your users to use on the side without them having to see it. And then they just use the flow as is. Okay, so where are we? So we had done the pre and post execution. We had done validating decorators and parameters because you can effectively do whatever you want at this point on the parameters and decorators. And the last thing is including code. So as I mentioned, imported step decorators and mutators are automatically packaged wherever they live. But you can also package arbitrary code as long as you basically put this at the top level of your package. Metaflow package policy equals include. The code will, two things. If the code is included in your flow, imported in your flow, I should say, and what it's imported from has this value in it somewhere, then it will be packaged. And I'll show an example of this. This is what the code package looks like today. So this is new as well, fairly recent. All the code that the user writes lives in the user directory, and everything else that is packaged lives in this .mf code thing, including Metaflow itself. Metaflow has always been packaged. It used to be present differently. You can ignore this. This is for like internal use files. But what this allows you to do is pretty cool. So I'll demonstrate this. This is just as a quick note, this does require the Netflix extension to work, but it does work. So say you have a mutator like this, that just basically, this one's on the documentation. It adds a decorator, it adds some packages, and then the user does something. Let me demonstrate this. Oop. Okay, so I won't run this due to lack of time, but I'll just show you how it ran. So this is the flow here. And you can see that effectively it imports this at dataset thing, which I'll show, and then it has the PyPy, and then it just basically gets some table and then prints it nicely. And the dataset you'll see is not in here; it's actually in a different directory. And so here it effectively includes DuckDB, PyArrow. So you can see that the decorator, the dataset mutator in this case, adds the libraries. So it adds the libraries with the PyPy decorator, and then it adds this process dataset decorator, which does this thing and produces this table. So I ran this on this machine. Well, you can see it over here. So I ran it over on this machine, and I'm not going to run it again because of the lack of time, but I wanted to show that on a different machine. So I have this different machine with effectively, and I basically told it to, I told it this. Let me I told it this Metaflow debug task inspect the flow name that I wanted to do. So this is a different machine, completely has nothing to do with the first machine. And it produced this, which is a notebook that has a couple of cells here, and then your code. And then you can basically kind of execute this whole thing yourself in your notebook. So for debugging, this is pretty cool. In this environment, you can see that, for example, I do have access to Rich. I do have access to DuckDB or whatever else. It is effectively in the environment that was run and with the code that was run. Yeah. Okay. So sorry, I went over a little fast on this, but I wanted to get to the end and leave some time for questions. Okay, so basically, and yeah, so one thing I could show this actually on. Okay, so yeah, this other machine that I was mentioning. So this is the code that the debugging that I would just look, and if you look at it, just to confirm, like the MF code directory is over here, and inside it, you'll have the dataset.py, which wasn't included in the original directory that I packaged, but was somewhere else and had those decorators. So I didn't have to tell it anything; it just automatically did it. Okay. So, oops. So basically, where are we now? Adding code to packages is also fairly straightforward. Last thing, meet Claude. If you guys haven't met, this is new guy that does pretty good at some coding stuff and is actually pretty good at building such functionality. So I gave it this thing, documentation. I suck at it, but it actually worked. So I want to build this user step decorator, blah blah, and whatever. So I did that, and this is what Claude spat out. So it nicely did all this all by itself. So it's a flow. So it was able to write the flow pretty easily. But what it was pretty able to do too is write this this library here with the user step decorator with validate that I don't have a secret keyword in it. And I did not write any line of this thing. I think I just commented out. It was raising an exception. I just wanted to show you the whole run, so I just printed it and didn't raise the exception. But so if I run it, it does exactly what you want to do, and it actually said, oh, I have this. There's this secret in your step and it's one of your artifacts. So yeah, this pattern is actually really useful for agents because they know how to do this fairly well. All right, last tidbit on this before I conclude. We improved the info command, which I think was already there before, that kind of tells you what your flow has. So this, I was looking at this is the dataset example. So it'll tell you, what extensions are packaged. In this case, for the dataset example, I had to use the the Netflix version so that I could get the whole integration with the debugging thing. It tells you, that you have this dataset.py that it included it, why it is including it, because it's processing this process dataset and dataset, and then it tells you what the user codes include. So this is pretty useful if you want to know what's in your package. Okay, what's next? We did all this stuff, but we're not going to stop here. Well, hopefully. This is a couple of ideas that we're toying with. Something like this, make flow. You can add a bunch of decorators on it too. You basically get the simplicity of a function and all the infrastructure of Metaflow, which would be maybe nice. The other one, we are planning to do programmatic construction of flows. So adding something like add step. Don't quote me on the syntax, it'll probably change. But you would be able to mutate, and this would probably be a pre-mutate and not a mutate, but you'd be able to modify your flow, the construction of your flow. So at this point, it opens up all sorts of UX for Metaflow. Because you could effectively have a configuration that's a YAML that would be passed into your flow mutator that would read your YAML and then construct the flow based on that YAML, or whatever your exotic favorite new fangled thing is to express your graph. What else do we have? Integration with external environments. So similar to the current at UV, we're actually working on this internally right now. That will kind of like read your external log file, but then import it into the Metaflow environment world so that you can use it as a Metaflow environment. Kind of extending on that, integration with tools like Pants or Bazel or any other thing like that to provide, effectively the mutator can then interface with like a package decorator and instruct Metaflow to add this package decorator with whatever it wants. Another idea that we toyed around last week actually was kind of a UV run equivalent, where at the top of the file you would document how to run your file, and we could actually read that and modify the command line with something like a mutator to do it. And then whatever else you have in mind. And if you're interested in any of these, let me know, because maybe you can help us.
There are two questions on the line. Is
That's
it
all.
possible to use this automatically add arguments with a flow execution, for example, package suffixes?
That's a good question. Did I put this in here? No. We have a PR for that, or at least an inkling of a PR for that. Right now, no. But the idea would be yes.
Okay, and then how is Netflix packaging, distributing these features internally? Also seems like there could be some sharp knives here with mutators. Are there certain patterns that should be avoided?
I'm not. So what do you mean? How is Netflix? I don't know whose the question is. Like
Brian,
Brian. Like what do you mean?
Brian's still online? Yeah, he's here.
I'm not sure I understand the question. And yeah, there's probably some sharp knives. We've tried to make it so that it's not completely stabby, but I mean, if you find things that don't work the way you thought they should, let us know. But I'm not sure about the first part of your question. Okay. Are there other questions?
Going once. All right. If not, thanks everyone for attending. If you do have follow-up questions, you know where to find us on Slack.
Yep. Thank you.
All right, bye.
Bye.